My name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and we are hosting together with the Graphene Engineering and Innovation Centre at the University of Manchester, otherwise known as the GEIC, today's session to focus on graphene application development and testing, in particular for using the GEIC facilities at the University of Manchester. I'm really proud and pleased to work with James Baker, who is the head of the GEIC, and he'll talk to us now a little bit about the facilities that they have and the capabilities. That'll be followed by a short presentation from myself talking about the partnership that we have together with the GEIC, and then it'll be opened up for questions.
Thank you, Terrence, and thank you, the Graphene Council, for inviting us to talk to everybody today. Good afternoon for those in the UK, good morning in the US, and already looking at the chat, we have people from around the world. So credit to the Graphene Council for bringing together the session today. So what I hope to do today is probably a few of you who probably aware of graphene, aware of what we're doing around the research and, more importantly, the commercialization agenda. But what I want to do is just give you a little flavour for the work we're doing around graphene commercialization. And also the opportunity for partnership, both with existing partners and from this new exciting partnership we have with the Graphene Council. So normally we start talking about sticky tape and pencil, and the creation and the discovery of graphene in 2004. And whilst that's the start of the story, around in Manchester 2004, driven by curiosity, the two researchers that led to the Nobel Prize for Physics in 2010, I want to really move on today from that story to talk more around the progress that's been made and for what I believe is a really exciting time in the journey of graphene commercialization. So first of all, moving on from the science, in 2010 Nobel Prize at Manchester, we received funding to build what's called the National Graphene Institute, a £61 million facility at the heart of the University of Manchester that today is not only looking at graphene, but is really looking at a whole family of these two-dimensional materials, and not just individual 2D materials, creating stacks, heterostructures of layered materials. So really today, this is the start of a journey around advanced, or as one of the colleagues said the other day, frontier materials. Those materials are going to start to change the way we design, we develop products in the future. So as well as the National Graphene Institute in Manchester, we also have the 230 million Henry Royce Institute. Again, this focuses not just graphene and 2D materials, but the broader advanced materials. There's also the €1 billion European graphene flagship that we're involved in, both research, but also starting to move into commercialization. So a huge amount of activity in fundamental research, teaching, and the discovery of these new materials, not just graphene, but a whole family of advanced materials. That's all I'm going to say today, really around the research. What I'm really going to focus on for the rest of this presentation is really the progress we're now making, not just on the research, but in converting that research into products and applications using graphene and 2D materials. And the particular focus of this brief is really around our second graphene building, the Graphene Engineering Innovation Centre, or the GEIC, as it's fondly called from Terrence's introduction. So this is a second £60 million facility at the heart of the University of Manchester. However, unlike the other buildings I showed, whose real focus is academic research, the focus of the GEIC is more about industrially led research. So that translation of that fundamental research into products and applications. So the GEIC has been specifically set up around partnership and collaboration with industry. And what I want to talk about is some of the capability of the GEIC, but also the business model and how we're building the ecosystem of partners. And through this opportunity with the Graphene Council, we're looking to extend that reach into broader companies, not just in the UK, but in the US and across the world, around how we accelerate this ecosystem of companies involved in graphene commercialization. So unlike the other facilities, the NGI and the Royce, the GEIC is really about that scale up. how do we take something from the lab into the marketplace and go from making a few grams or a few centimeters of something into that scale up of continuous production, measuring things in the GEIC by the kilo or by the meter squared. Because if we're going to go into a factory, we need to move into the ton quantity, we need to move into the large area. So the GEIC is very well positioned around that scale up. And if we were there today, I would encourage you, I think in Terence's read ahead, if you go onto YouTube and Google Graphene Manchester, you can actually have some 360-degree walk-arounds of the GEIC facility. You can see some of the videos that were produced all about the capability. But you'll see it's very much a more factory-like business. It's not like a normal university facility. It has the ability to have large pilot holes, as you see in this picture here. And we can both make graphene and 2D materials, but more importantly, we can focus on applications. So in a way, it's also about this rapid prototyping. So one of the challenges of new materials is it can take many months and many years to go from a lab through that scale up, through prototypes, into a product or application. So what we've designed the GEIC to do is really that rapid progress through something that traditionally takes place in a university lab into that scale up and rapid prototyping. And I'll come back to that when we talk about collaboration later in the presentation. And again, just a few more pictures. You can see some of the different labs and capabilities we have in the GEIC. Again, I encourage you to go online to see a little bit more, to actually see what it looks like, to get a feel for the size and the shape of the facility. In terms of what the GEIC does, and again, Terence gave a good introduction, it can produce material. So we are producing graphene, both top down and bottom up. So again, for those who are familiar, top down is taking graphite, breaking it down into layers of graphene. Bottom up, for example, CVD, chemical vapor disposition, where we take a gas like methane to create a layer of graphene onto a substrate. So we can produce graphene materials, but as Terence said earlier, this is more about the creation of supply chain. We are a university, we're part of the University of Manchester. We don't want to be the supply chain responsible for making graphene by the ton or by the kilometer squared, but we want to work with industry, whether that's an existing material supplier or a new material supplier, to accelerate that production of the material at quality, at cost, at consistency. And I'm sure amongst us today in the audience, we have a number of graphene manufacturers who can now produce graphene under REACH registration, for example, at a consistency, at a quality. But I'm sure many of you in the audience also know that one size doesn't fit all, and that there are many different types, qualities, and forms of graphene, depending on the manufacturing process. So the GEIC can support graphene manufacturers, or it can also act as a broker to introduce people who want to use graphene, and act as a broker around introducing you to those suppliers who produce those different forms of graphene. But we're not just looking at graphene, we are also looking at production of other 2D materials. And just to give you an example, we are looking at boron nitrides, palladium disulfide, and MXenes, just to name a few. But certainly graphene is the one that is the most advanced. And already you're seeing real advancements in the supply chain. And I'm sure Terence will talk a little bit more about that later when he talks about his survey. So as well as material production, the focus of the GEIC is really around application. So that's everything from composites, and I'll dig a little bit deeper in a moment in these areas, printed electronics, energy, and membranes and coatings. So it's from many sectors, from aerospace to automotive to energy to healthcare, but a broad capability of laboratories that not only produce material, but also can do the formulation, the coating, the mixing, and do that in a rapid way at a scale that is representative of what takes place in industry. Again, I stress, we're not trying to be a production house, but we're trying to bridge that gap between traditionally what takes in the university and what takes place in a factory, but it's very much a partnership and collaboration model with industry. So if I take production, I've touched on, we can do both top down. taking graphite and breaking it down. But we also have a significant capability around CVD, plasma vapor disposition PVD, and a whole range of other capability, not just looking at graphene, but looking about how we might move into roll-to-roll CVD type production on a substrate like copper or nickel, or potentially directly onto a copper material. So again, public domain information, coating copper wires to see if we can reduce the mass of copper, for instance, in an aerospace application, is one of the areas that we're looking at. So on the picture there, we see our roll-to-roll capability that is now being commissioned. So we can now produce not just at the 10 centimeter or 50 centimeter square scale, we can now move into roll-to-roll production of CVD graphene as an example. But there are companies out there who can produce CVD. We want to work with those companies, but more about how do we take that CVD and we implement it into one of those applications that we're going to talk about. One of the challenges that you all have around performance is it's difficult sometimes to say what the performance of graphene is in a product or application. But what we want to see is when you integrate graphene or add graphene into a battery or into a structure or into a component, how the actual output of that product improves in performance. And that's what the GEIC set up about, is that integration of the graphene into these various products and applications. In terms of composites, structures, we can add graphene into everything from rubber through to resins, through to plastics, thermosets, thermoplastics, into carbon fiber. So here, for example, we have an autoclave. This has been quite key to adding graphene into resins to develop, to mix into carbon fiber, not only to produce test components, but actually to produce components for aerospace and automotive. And we can actually produce that component and test an actual integrated graphene enhanced carbon fiber component at a scale of around a meter, meter and a half by approximately a meter, using an autoclave, just to give an example. So again, very much around pilot scale, but also about that rapid prototyping to produce a component or a sample that you can test either on a test rig or you can prototype as a development to de-risk your particular product or application. So again, in terms of capability, we will share a full list of all the kit that's involved in the GEIC. But our business model, as well as having a facility, is we have equipment and kit that partners can have access to. They can have access to the kit, they can have access to the kit plus a technician, or they can have access to the kit, a technician, a specialist, or even we can have academic input from the rest of the university that makes sure that what we're doing is still built on fundamental sound science. And as well as the science, we can supplement that by rapid prototyping and producing of test pieces that we can test and measure. So going through the whole of what we do in the GEIC, and I'm sure Terence will cover later, is a whole breadth and depth of test capability, not just in the GEIC, but in our adjacent buildings like the NGI, the Royce, and our partners can have access to that rapid test and measurement so we can ensure what's taking place and understand any measurements and capability that's taking place, all within one building or within the surrounding facilities of the University of Manchester. Energy is an exciting area for me, maybe longer term. Structures and composites are moving very quick. I'm sure you've all seen test cases of, for example, Ford, who put graphene into foams in their motor car, through to graphene shoes, where you put graphene into the rubber, through to tires, through to structures, BAC Mono, being a sports car in the UK as an example, looking at graphene in composites. And we're also working with the likes of GK and Aerospace, Airbus, around putting graphene into aerospace components. Energy, for me, is a really exciting area. The drive towards more carbon neutral, more electric aircraft, electric vehicles. So everything from the production of batteries through to fuel cells, through to supercapacitors. Again, we have the ability in the GEIC to do that integration of graphene enhanced components into pouch cells or into coin cells, so we can make or manufacture that complete integrated component. So again, a full list of capabilities can be on our website. But again, it's a broad capability around energy storage and batteries. And for me, an area of potential real growth is that of starting to combine, for example, energy storage with structural. A lot of integration takes place between these different labs and capabilities. Membranes and coatings, again, a very interesting area. Everything from anti-corrosion coatings or barrier coatings through to the potential to make a graphene coating or a graphene structure or layered structure that acts as a membrane that ultimately could do water desalination, as an example. And what you see here, for example, is our roll-to-roll capability. So again, think of the GEIC as a sort of a waterfall capability. We can start on the bench, making a centimetre squared. We can then progress up to making, say, a 30 centimetre squared structure onto a mid-size membrane. Then ultimately we can go into this roll-to-roll that can produce, I think it's 40 centimetres wide by meters, tens of meters or hundreds of meters. At full pace, this machine will be running at 100 meters plus per minute or hour, depending on the coating. But we can tune that process to go through different baths, different treatments, to look at putting different coatings down for different types of membranes or coatings or applications. So again, a really exciting development, but a key message of the GEIC is we're working in this case with Mattis, who make production coating lines, to develop that standard production kit for the coating of graphene and 2D materials onto substrates. So a real capability that's probably unique of its kind, but developing the processes to take from the lab into that scale-up being a key message. Printed electronics, again, a very exciting area, everything from wearables through to sensors, through to RFID. Again, look on our website, you'll see some examples of the kit. In operation, we actually printed some Christmas cards as an experiment over just before Christmas, but that continuous production. Again, using the waterfall principle, we can do simple inks, simple coatings, 3D printing, through to printing onto a 1.1 meter substrate, whether that's fabric or a plastic or a wing skin, for example, through to what you see here is a roll-to-roll, where we can actually produce sensors or printed inks by the significant quantity. So again, with the GEIC, you can start off with the science in the NGI, you can then migrate to the GEIC to start scaling it up, or you can move into that rapid development and scale up in a very quick concurrent engineering type of way. So again, quite a core capability on inks and printed electronics. Core to a lot of this, as I touched on, is measurement and characterization. We also recognize in the GEIC that some partners want to use projects, want to do a collaborative piece of work, and that is our core model. But we also have access to about £1 to £2 million of test capability alone in the GEIC. That's complemented by test capability in the NGI and the Royce. We're also working very closely with our partners, the National Physical Laboratory, NPL. Again, people may have seen in the press in the last couple of days, we've just signed an MOU with NPL between the University of Manchester, so it's broader than graphene. But one of the intents is to create an NPL base or laboratory in the northwest of England, probably around, if not in the GEIC, and that will give us greater capability to facility and equipment beyond what's currently in the GEIC, but also extend that measurement and characterization capability, the development of standards in partnership with NPL and other supply chain going forward. So coupled around that, the facilities, what we are very much is around collaboration with industry. I mentioned industry pull is our model. We really look to address key challenges or key industry challenges. We still do some technology push. If I look at CVD graphene, we are still developing new capabilities, new technologies, but there is still some market development. But as a general statement, we work with industry partners around those challenges or those problems, be them end users. If I use aerospace as an example, we have people like GKN and Airbus, Kinetic. We also work with a supply chain, people who make components that go into graphene, as well as those companies who make graphene materials or the polymers or the plastics or the carbon fiber, to give you an example. What we allow with our members, so it's built on sort of a membership type scheme, and we're going to touch on this with the conversation today, the Graphene Council, and now what we call a Tier 2 partner. So our partners can have their own private lab in the GEIC. So that's with your own staff, with your own equipment, using your own activity in the GEIC. We're responsible for health and safety, but what you do in that lab is your own business, your own confidentiality, under your own lock or key, but you can lease that private space. We also have what we call shared general labs or Tier 2 labs. So for small businesses who haven't got their own R&D lab, you can have access to a shared lab for a day or for a week or for the course of a project. So again, particularly important for those small startup or SMEs, small medium businesses or spin-outs. And a number of those are members of the University of Manchester from academics or from students from the university. We allow them to have some space so they can do some of their work in that general lab. So on the ground floor, we have all of our shared equipment, all the collaborative equipment. And on the first floor, there are a series of labs that are either private labs or they are shared labs. Clearly, we have a full technical support team. So that's everything from health and safety through to risk assessment, through to some procurement of some chemicals and activity. We clearly, in normal times, have a series of conference and meeting rooms that our members are able to join. So, for example, Terence, if he's in the UK, being a Tier 2 partner, can use some of those meeting rooms in the GEIC as part of his membership offer. So again, they're on a booking basis, but in normal times, our partners have access to facilities and equipment and meeting rooms if you're in the UK or in Manchester. Hot desks, office space, and our organisation for our Tier 1 partners and for our growing Tier 2 partners, we do have dedicated application managers, if you like, a key account manager who works with you to make sure we're working well on those projects going forward. And we also have what we call affiliate partners, which aren't necessarily graphene companies, but it could be IP lawyers, bid writers, HR companies. So people who are looking to scale or set up a base in Greater Manchester, we give you access to some of those skills and organisations who can support you in your business setup or organisation if you are coming to the UK or you're based in the UK. So again, quite a broad set of capabilities available for members. And today, these are just the partners for the GEIC, and we've been open nearly 2 years now, just over 2 years since the grand opening, but operational for just over a year. And we've worked with over 150 industrial partners to date in both NGI and the GEIC. But these are our partners, and there's a few more that we can't talk about, but coming on board. And you'll see there the Graphene Council, one of our latest Tier 2 partners. And through the Graphene Council, we're developing a new model that can get access to even more companies through the Graphene Council to engage in this ecosystem of end users, supply chain, and support businesses that work on graphene and 2D materials. So just a final couple of slides before I hand back to Terence, very much around the principle of our model. We have this facility, we have the equipment, partners can get access to that facility, access to the equipment, access to that knowledge. But our business model really is around collaborative projects. What we really want to do is, starting on the top left, is to engage with industry with a problem. It could be, for example, you want to make your aircraft lighter weight. It could be that you want to improve the range of your battery. It could be that you want to improve the performance of your coating, anti-corrosion, water absorption, barrier coating. So very much a problem-led area. What we look to do in a collaborative way is work with you, with your engineers, with your organizations, coming up with what graphene might be able to do for your problem. So by adding graphene to a rubber, can we get a rubber that is both soft and grippy, but also more durable, to give you an example? We can then do some very rapid research, and that could be a brainstorm, it could be a workshop, it could be a 6 to 12 week piece of work. We call it a pathfinder that goes out and looks what's in the market, what's taking place in academia. So some of the big challenges, this could take days and weeks. For other challenges, it could be a brainstorm over an hour or a morning or an afternoon. We then do that brainstorm, that research, that design. We might use artificial intelligence or tools. We then very rapidly move downstairs to make something, a prototype. We then quickly test that using the capability, using the philosophy I call of make or break. If it's going to fail, we want to fail fast and learn, or if it works, move on and rapidly move. So through the Graphene Council, we allow the partners to do that very quick, rapid experiment. If that then works, and you now have a business case to move on, hopefully we can migrate into a bigger project, but we've done that de-risking and we can iterate that into a bigger project, or fail fast, move on and learn. So again, as a principle, we're looking about creating supply chain. We work with our partners around those problems, rapid test, rapid prototype to accelerate into products and applications. And very simply, what we're trying to do, if you look at the journey of a technology from the university into the market, we start in the bottom left as a university. So we have access to that academic depth and breadth, over 350 researchers working on graphene and 2D materials. But increasingly, as an example, we're now working on graphene in construction. So we're now starting to access other parts of the university. In the University of Manchester, an organisation called MACE, Materials and Construction Engineering, Aerospace and Construction Engineering. So we've now got access to even broader pool of academics who aren't graphene specialists, but maybe a specialist in construction or architecture or buildings. So academia is core to what we do. NGI is about that concept development, moving from low TRL into mid TRL, but still academic led. GEIC, very much in that valley of death and that scale up. And key to that is collaboration with industry. So I'll finish there. Hopefully I've given you a flavor for the capability. But for me, quite exciting to be working with all of our partners and our new partner of the Graphene Council. We've had a great relationship with Terence over the years as part of the Graphene Council. The network and the ecosystem that Terence brings to this discussion, what we're really looking to try and build are those collaborations and partnerships that actually accelerate the adoption of graphene into the end use. And just one final word, just as an example, one of our partners is Highways England in the UK, looking at the road network. We probably need to have the equivalent in the US. But if we can accelerate the adoption of new materials for roads, for crash barriers, for road markings, and we can show a business benefit that by adding graphene, it improves the maintenance or the performance or the productivity of the roads, we can really start to bring the whole supply chain through, not just graphene manufacturers, but companies who make concretes, through to steels, through to coatings. So again, some really interesting examples taking place at the moment. And I think through our relationship with the Graphene Council, that will accelerate as we go into the next weeks and months. So with that, I will hand over to Terence. For me, we're trying to create what we use. We pinch this from America, from Silicon Valley, Graphene City. But Graphene City doesn't mean everything's in Manchester. We want a hub or a heart in Manchester, but through access, through partners around the world, we're looking to collaborate using the kit, the capability, the know-how to accelerate the adoption of graphene into applications and products. So with that, I'll hand back to Terence and then happy to take questions at the end. Thank you.
Thank you, James. It's excellent and really appreciate it. And likewise, we highly value the partnership that we have with you and the entire extended family at Manchester. So I'll try to be brief, but what I wanted to highlight in today's presentation together with James and the colleagues are some initial results that we got back from our 2020 survey, which was completed at the end of 2020 and published on the 4th of January of this year. We had more than 800 replies to this survey, which is twice as large as the previous one we did several years ago. And what was quite interesting is the validity of this data. We had more than 65 different countries that were represented in the responses. 1/3 of the respondents were from the academic sphere, 2/3 from the commercial world, which mirrors our population in the Graphene Council network of more than 30,000 material scientists, which are likewise 1/3 academia, 2/3 commercial. And the respondents included people who are producing graphene, people who are buying graphene, researchers, application developers, and users. And in some cases, of course, the people participating are both a producer and doing research, for example, or a buyer and doing application development. So if we look at how this is broken out, the highest percentage of frequency of response, and again, the totals will add up well over 100% because people can do more than one thing. But the vast majority of, or the highest frequency was people who are actually using graphene in an application, which if you had asked this question several years ago would not have been on the top. We have an interesting cohort of respondents this year of folks that are not yet using graphene, but are evaluating it. And so when we do the more detailed splits of the data, which we will share with our membership, with the organizational membership and partners, we're going to look at how this splits out differently from those that are using applications now, those that are not yet using graphene and what they're looking at, et cetera. And then we divided the application development from the commercial sector. So that's where you see develop applications, and then in parentheses, would be commercial application development versus academic, again, to see how that splits out and compares. But that gives you a sense of who replied to our survey. And in this case, we simply did this by alphabetical. We have also got it ranked by frequency. But what this shows you is which applications our respondents are working on. And so some obvious ones pop out, like the composites, thermosets, and thermoplastics. Things like energy storage, battery technology is an incredibly hot topic today for obvious reasons, especially with the advent of electric vehicles that are definitely going to replace internal combustion. It's just a question of when. We see films and coatings very highly ranked. We see plastics and polymers. One of the reasons, of course, is that graphene can fairly easily be integrated into these materials and give a really good performance lift using a very small amount of material. So that's a near-term application. Structural materials, and that would include things like cement and concrete. And then you see the others, textiles and fibers, for example, is an area that we've seen a lot more activity and actual product in the field with product available in terms of clothing that are enhanced with graphene. One of the other questions that we asked was which performance characteristics or performance properties of graphene are you most interested in? And we asked, to label it either as an essential feature, an important, an interesting one, or not needed. And electrical conductivity, on the one hand, is not surprising because graphene, of course, is so highly electrically conductive, the incredible mobility. But on the other hand, it's not suited for semiconductors necessarily at this stage, although it's making inroads there. So the electrical conductivity one is interesting that it ranked almost half of everybody who replied said it was essential. Thermal conductivity, electrical charge storage, et cetera. You can read the numbers for yourself there. And what we will do in the more detailed breakdown is go by application and then look at the attributes so that we can see for application X, which particular attribute of graphene is most critical based on what people respond. And the next, another question that we had was on the material characteristics itself. So things like dispersibility, surface area, layer count, et cetera, some of these characteristics. And it is quite interesting to note dispersibility came to the very top of the list. Again, if you had asked that question several years ago, that would not have been the number one response. And I think the reason why we see it at the top of the list is that today so many more people are actually working with graphene and putting it into a host matrix. And they've discovered that dispersibility is an absolutely critical feature of this material, especially when we're talking in some cases of load factors that are well under 1%, in the tenths or even hundredths of a percent by weight. So an extremely small amount of material, making it absolutely critical that it is dispersed throughout its host matrix. The surface area measurement, of course, is quite closely related to dispersibility and the rheology of the material. The layer count is likewise closely aligned. And then we come to purity and some of these other aspects of the material. And so if we go to, again, a detailed analysis by application, what type of performance characteristics people are looking at, and then what physical characteristics of the material are needed, which is on this slide. And we can draw a very accurate picture of what's required by application. Now, we had another area that provided, I think, some interesting and maybe unexpected results, and that was the types of graphene that are being worked with, whether it be in research or in application. And the number one response, almost half of all of the respondents indicated they are working with some form of functionalized graphene. Again, this is interesting because not all graphene is functionalized. I would say a small percentage of the material that is produced and used commercially is functionalized or manipulated in that way. But we see that it is at the top of the list for materials being used right now. Graphene oxide, likewise, comes quite high on the list, which is interesting because graphene oxide is not produced in perhaps the same quantities and has other processes that are not as easy for producers to stand up and start producing graphene oxide, but it's quite highly ranked. And then we get into the other forms of multi-layer or few layer graphene. Quite a bit of graphene is produced in powder form, of course, and then you see the rest of the responses there. And we included graphene quantum dots, and a not insignificant 14% of the respondents are working with graphene quantum dots, which is interesting to note as well. Then we had another question that related to standards and business practices. So we had a mix of questions here. And I want to point out one that's actually at the bottom of the list or near the bottom of the list, and that's the nomenclature and definitions. There has been quite a lot of discussion about this particular topic over the years, but once ISO came out with its standard definitions and accepted definitions, that issue is somewhat settled, which is why I believe it falls down near the bottom of the list here. Although, point of interest for everybody on this call, that paper is already now up for review. So we will be looking once again at the official ISO nomenclature and definitions for graphene. And as the Graphene Council is part of the TC 229 working group on these items, if you have an opinion or would like to get involved with those standards review processes, please contact me and we will be happy to work with you on that. At the top of the list is the measurement and characterization methods of graphene materials. This is a very hot topic in the standards working groups, and it is not a surprise that this is at the top of the list. It is also interesting that it aligns well with the focus of the standards groups, which are working right now on setting standards for these measurement and characterization methods. One of the hottest topics that we have to deal with, though, is that from a what should I say, a very robust perspective of how to really, in great detail, characterize graphene materials is one approach. But the issue that we're bumping up against is that in a production environment where you need to have rapid and relatively inexpensive ways of characterizing the material for quality control processes, these other more extensive using XPS or AFM or some other expensive and processes that are not rapid to characterize the material is a conflict, right? So we want to be able to characterize the material to a very high degree. And by the same token, if it becomes too cumbersome, too expensive, too slow for a production environment, these standards will simply not be used in the production environment. And so that's a circle we're attempting to square at the moment. The other item I want to bring to note is the health and safety declarations, especially as graphene becomes more commercially utilized. It will come under more and more scrutiny, and that's where you have the REACH restrictions or you have TSCA requirements in the United States and other registration processes that will become more stringent, especially as the volumes increase. And this is an area where we need more information and data about the health and safety profile of graphene materials. Then the last question that we had asked in the series was, what do you think is the greatest obstacle to greater commercial adoption? And there are no surprises here. The number one rated response was cost or price, followed by the ability to scale up to a large amount of volume of the material and making it readily available. And the third was consistency or batch-to-batch reproducibility of the material. The fourth one on this list, I think, is an interesting key to the rest of this, and that's lack of knowledge and awareness, especially in the end user community. And I would add not just a lack of knowledge and awareness, but a misunderstanding of the material. Because of all the hype around graphene, especially after the Nobel Prize was awarded, there were some pretty eye-popping numbers in terms of costs, $50,000 a gram or something insane as far as how expensive this material was. And graphene received this perception that it's just prohibitively expensive and will always be prohibitively expensive. But if you look at what's happening today, we see massive scale being put into the supply chain. Most notably, recently in October, NanoExplore commissioned a 4,000 metric ton per annum automated plant for the production of their material. And certain forms of graphene and nanoplatelets are getting into the $25 a kilo price range, which is quite different than some other forms of the material. And even the more expensive forms are not that expensive in the end application when, again, you're adding them at these incredibly low load factors of under 1%. And so there's this perception that graphene is unapproachable because of price, but I would invite anybody who's looking at this to take a second look, because prices have come down, scale has definitely improved, and the production quality, consistency, batch to batch has likewise improved with the leading producers in the field. And so those top three obstacles, while they are valid, could also suffer from misperceptions or outdated information. So I want to talk just really briefly and bring this back to the discussion that we have today about the partnership between the Graphene Council, which reaches an incredibly large ecosystem, and the innovative work that's being done at the GEIC, which I think is quite unique and quite forward-thinking in the environment. As James said, there are 6 main areas: composites, energy, membranes, inks, graphene production, and measurement and characterization that the center focuses on. And then you have behind that the more than 300 highly qualified academics who are at the University of Manchester, which are also reachable through this kind of partnership and collaboration. And we're extremely proud and grateful for the close partnership that we're able to have with the GEIC around Tier 2 membership benefits, which are only available to Graphene Council member organizations. So it is a prerequisite for you to be a member of the Graphene Council to access this partnership, which itself has its own conditions. But I think what's really interesting, and I want to kind of highlight or add to what James had presented, not only is it an advantage to get access to a facility with all these capabilities, but for a lot of large companies that are unable to turn over their production lines to test runs or do not want to run the risk of contamination in their facilities, et cetera, you have industrial scale equipment in this facility at the GEIC where you can run production simulations and do the prototyping, et cetera, in the safety of a lab that's outside your own production facilities. And then tap into not just the equipment, but also the capabilities, the intelligence that's there at the facility. So we think this is quite unique in the world. There are some other facilities that may have bits and pieces of this, but this is quite unique with the GEIC and the ecosystem that they've set up. And this extends not just to the facilities at the University of Manchester, but the National Graphene Institute, which is at Manchester, the Henry Royce Institute, which, by the way, the Henry Royce Institute is also a member of the Graphene Council. And that Institute for Advanced Materials really networks all of the equipment and facilities throughout the United Kingdom at the university level. So if there's a piece of kit that you want access to and it may not be available in one facility, that network should be able to locate it for you, especially for those of you who need specialized testing. The other thing I want to talk about, and I'm going to borrow on the slide that James had shown earlier, in where does the Graphene Council fit in this? is I really think that we do have a large academic community within the Graphene Council to facilitate networking and information sharing, but we're prioritizing and highly focused on the commercial end users. And that's where the Graphene Council interfaces with groups like GEIC World for Composites or the American Composite Manufacturers Association and other vertical industry groups where these applications will find themselves to connect the dots with the end user community. And so for those of you on this call who might be a graphene producer, and for those of you who might be a potential or current end user, the Graphene Engineering Innovation Center, together with the Graphene Council, is a great way to bring together parties to rapidly develop real-world applications solving real-world problems, and then use our platform to help you publicize and raise awareness about that to bring it to market and accelerate its adoption. That's I think the continuum that we have here. We each play in our own sandbox, if you will, but we have very complementary sandboxes that we play in and can use that. So, why would you join the GEIC as a Tier 2 member through the Graphene Council? We actually have staff as the Graphene Council. We're actually incorporated in Manchester now, along with the US, Switzerland, and an office in Brazil at the McGrath Institute. But we have staff in the UK that can help support the project. So that's an advantage. We are in frequent communication with the GEIC and have a fairly good understanding of the capabilities and can help you to navigate that instead of trying to do that on your own. So that should be more efficient. And we can help connect the dots with other partners. So if you wanted to run a test program or you wanted to prototype, but you also were looking for an end user as a producer, or if you're an end user and looking for a qualified graphene supplier, the Graphene Council can help you to do that vetting and to connect the dots. So I'm very happy to announce, of course, that Abalonics Materials and Standard Graphene are both members of the GEIC Tier 2 Consortia membership through the Graphene Council. And we will be working with both of these organizations and other third parties on testing and application development for them for their commercial use. And so this is a perfect example. This is not a theoretical partnership. It's actually in place. These companies are in place and we're already working together on this. And with that, I'm going to end my presentation. We'll take questions. We'll read through the chat box. And I know we have Ivan Buckley as well from the GEIC on the line as one of the panelists that can help us with answering questions. So if you'd like any information on how to become a Tier 2 Consortium member, or if you're not yet a member of the Graphene Council and you want to find out about benefits of membership as an organization, you have my contact details there. I'm going to go ahead and stop sharing them now, and we'll just go right to the Q&A, and I'm sure we've got plenty of questions. So Ivan, I'm going to call on you if you don't mind. If you want to read one of the first questions out, and then I'll have a look myself.
Yeah, hello all.
Put you on the spot a bit, Ivan, huh?
Yeah, just an interesting question. I was just replying to some questions. James, interesting question from George Stenker. And George, apologies if I haven't pronounced your name correctly. What are the plans for facilities in the United States?
Yeah, no, I saw that question, so I wasn't answering it. So we are part of the University of Manchester. So we're university based in Manchester. So the University of Manchester doesn't have plans, to build a facility in the States. However, we are exploring partnership operations. I'll give you an example, not US, but the GEIC is part funded through United Arab Emirates, Abu Dhabi. So I'd like to say it was all about graphene, but it's probably as much to do with football, soccer. For those who are familiar with football in Manchester, we have the Blues and the Reds. So Etihad support the Manchester City Football Club, and as part of that broad package, we are exploring opportunities for partnership in Abu Dhabi, which could include innovation centres, investment, and a whole range of things. I raise that in the past we have been to the US. We were actually in Capitol Hill in June of 2019, and there was a bit of dialogue taking place at a government level around potential collaboration between UK and US. So simple statement, we as University of Manchester don't have plans to have any operations in the US. However, as Terence very well pointed out, Terence has an existing and established network, including many end users, supply chain, ecosystem from the US. And that's one of the reasons why we're working with Terence and the Graphene Council to join those dots. For me, maybe it's a conversation we can have at some point. Capitol Hill discussion was around potential partnership collaboration. I probably should be careful with my language here, but you have a new president here. But could we have a UK-US trade deal of which advanced materials might be at the heart of it? So I wouldn't rule it out. We have no plans, but I think there are some great universities in the US. And for me, though, it's not about the university collaboration. As Terence said, it's really that translation piece that needs addressing. The closest I'm aware you have in the US is probably some of your defense assets like the Skunk Works and Phantom Works that you have in the defense sector. So DARPA, is there an opportunity to maybe do something around maybe some of the defense or aerospace type programs? But you probably would need one of the big American primes like a Boeing or a Lockheed Martin or someone to support that. So I think there's opportunity. I'd be keen to explore that probably through the Graphene Council. I think this is an area not just on graphene, but this whole advanced materials is a really exciting area going forward. I haven't really answered your question, but simply we have no plans, but we're talking to the Graphene Council, and I think it could be an area of opportunity for the future.
But you do have facilities in the US, but it's not quite the same as what you have at the GEIC in terms of this rapid prototyping and development. The facilities aren't quite exactly the same. So it would depend on the application area, but you do have, Penn State University, University of Michigan, UAMI Advanced Materials Center in Utah, the Oak Ridge National Lab, for example, in Tennessee, are a couple of facilities that, we could basically, if people have questions about this collaborating, you can use the GEIC from a distance as well. And that's part of the value add that we offer here, is helping you to do that. One of the questions that came from the delegates that I'm reading here: what are the very first steps your partners take to start a partnership with the GEIC once they present you a challenge? From which point do you need to formalize the partnership to start testing and prototyping? And then how do you charge them? And if so, before they become a permanent member? And if you will, James, allow me to answer that briefly, and then I'm sure you'd have some comments on that. The GEIC itself has a membership model, and I'll let James speak to that. And so there's nothing prohibiting anybody on this call or any organization anywhere from going directly to the GEIC and becoming a tier 1 or a tier 2 member directly with the GEIC. We do have some conditions that we try to make it advantageous for our member companies within the Graphene Council to join. And then you would join as a consortium member through the Graphene Council, which gets you a number of credits that then can be used against either equipment or personnel or both at the GEIC according to your project. And the value add that we do as the Graphene Council would be to consult with you about what kind of projects you want to run, to try to do the scoping and make sure it's well defined before engaging with the GEIC, which to their credit, I know that they're incredibly occupied with projects at the moment because they do such a fantastic job and because it's such a unique facility. And so to help you navigate that, that's the value add the Graphene Council brings to its members that go through the consortia, but you can go directly to the GEIC. And so, James, do you want to add to that?
I mean, when we set up the GEIC, I touched on earlier that traditionally it takes many years to just do the technology piece and development, and and take months and years to go through the different TRLs or stage gate process. Also, I'm sure you've got different experiences, and there's probably universities on the line, but universities aren't always the most easy to deal with. It can take, Ivan and I were talking the other day, I think before the GEIC, it probably took us from first conversation, probably 9 months typically to have the conversation, put a non-disclosure agreement in place, talk about a challenge, come up with a contract, negotiate it. So the GEIC has tried to develop, as Terence has said, like a membership scheme. All right, there is a threshold. Some of the questions is £40,000 is a lot for a startup. But for me, we've come up with a framework membership agreement, which we call Tier 1, Tier 2. So you sign up to a framework contract, which has terms and conditions. You pay for the work you do. In the GEIC, typically any foreground IP that you develop is owned by the industry, not by the university. It tends to be a very emotive area in contracting. So again, we've simplified that, but background we might bring to the table existing, but any new foreground IP know-how for that field or scope of a project is owned by the partner. So we have a framework agreement, you sign up to that. Then as Terence says, once you've signed up, the ability to translate that into a short project or using a piece of kit or a longer term project is quite quick and agile. So there is a threshold to get through. A few questions is typically sign an NDA, sign up to the partnership agreement. Once you're there, you can move very quick. And again, my record or our record is we've actually signed a company up for a tier one agreement, £200,000 a year in a day timescale. So depending how many lawyers you have in your company, it probably take you more than a day. But we do have Airbuses, GK and Aerospace, Kinetic, AstraZeneca, as well as mid-sized companies, as well as small companies. I'm aware it is a threshold. In the UK, if you are a small business based in Greater Manchester, we do have a program called Bridging the Gap, which enables small startups or businesses to do some initial work before that 40K. But we've deliberately made the geek so it isn't just open for anybody to come in and just spend £1,000 or £500. So apologies for that, but not apologies. What we really want is that deep, engaging relationship. In the UK, we have Bridging the Gap. And what Terence is doing a little bit through the Graphene Council is reaching out, probably lowering that threshold a little bit further as well. So again, if £40,000 is within your remit, come and talk direct. If that's a big issue, then Terence has given an opportunity through the Graphene Council Consortium to maybe support those smaller businesses. So again, I'd encourage you to talk. We are a charity. The University of Manchester is a charity. We're not a profit centre, but we have to cover our costs. So we charge for access for projects, access to kit. What we're quite fortunate, we've got £121 million of facility funded by UK government and by Europe and by Abu Dhabi. We don't charge per se for the building of that building. We charge for kit access, for overhead, for people time. But as a result of that, we can't just give time for free. In the UK, and I'm sure you have this in the US around trade deals, it's called state aid. So unfortunately, you have to pay to access the facility and the equipment. We can't do that for free. We have to charge an economic rate. So there is a cost associated. But what we're really trying to do in terms of an output is not just, we're trying to cover our costs through membership. What we really want to do is for you to succeed with your products in the market. So we also have a scheme whereby you own any foreground IP for the project, but we look for a royalty payment based on a success fee. And if your product goes to market, we look for a small share in that success that we can reinvest into the building, into equipment, into teaching and training for the future. So again, we're trying to get a sustainable model here, not just for graphene, but for the next 40 years around graphene 2D materials and advanced materials. So again, long answer, but please contact Ivan or Terence if you want to find out more. But for me, it's not just big companies we want to work with. We absolutely do want to work with those small companies, those startups. One further pitch, and I'm sure Terence can do the same. We do help small businesses bid for grants, as an example, that can help you pay that 40K. So in the UK, there's an organization called Innovate. In Europe, there's the Horizon. In America, there's SBIR. So again, we might be able to help you to actually bid for money that helps you pay for that fee or pay some of that fee to enable you to get onto that ladder. So again, we do support like that to support businesses of all sizes and shapes.
Excellent. Thank you, James. We do have a couple more questions, but I think for the majority of what we've discussed, people are asking, how do we access this ecosystem? How do we take this forward? I'd like to leave everybody with just a couple of thoughts. The Graphene Council is truly a global network. We have members from Australia, Korea, India, Europe, South America, South Africa, North America, etc. The University of Manchester and the 3 dedicated facilities they have to these advanced nanomaterials are really centers of excellence on the planet. Together, between these 2 ecosystems, all the way from basic academic research through to commercialization, you do not have better partners anywhere on this planet between the two of us, the two ecosystems, to get a product from concept to production to commercial adoption. So whatever stage you're at, if you're not ready yet to do, a dedicated lab in the facility, that's fine. But if you are in this sphere and you're working with graphene and you're interested in commercialization, one way or another, between the two of us, we can help advance the ball and connect you with the right partners. And I think that's kind of the takeaway. It's important that people know what is capable at the GEIC, and through this facility, it's something quite unique and quite valuable. And if you can't take advantage of it today, there's a chance if you're still in the graphene field tomorrow, it'll come in handy. So just engage with us, whatever stage you're at. We'll try to answer your questions and be responsive to what you need. From my side, James, I don't know if you have any closing statements, and Ivan, we really appreciate working with you guys and the team. I think we talk about once a week, or it feels like we do. And, to try to keep in contact and with what's going on. And from the Graphene Council, we're very proud to be a partner and hopefully facilitate the utilization of these valuable assets. Did you have any closing comments?
Personal comment, but I think very interested with Terence's report. If you hopefully you have access to read that. But for me, we're in a very interesting stage. I started off with 2004 to today. That's 16, 17 years. Typically, carbon fiber, as an example, was 25 years before early commercialization, but already you're seeing a real pace. In the GEIC at the moment, we have over 50 live projects, from membranes through to coatings through to batteries. So there really is a real growth in terms of rapid development of prototype concepts, product. You can buy shoes, tires, electronic components. So for me, we're in a very interesting stage of the development of graphene commercialization. I'd encourage you, if you're interested or want to take that step forward, of making contact with Terence or Ivan or the team to see how we might progress that. But thank you for listening.
Excellent. Well, with that, I think we'll close today's webinar. Thank you for your attention. We'll send a link to the recording within about 24 hours. We'll also send a copy of the slides that you've seen today, and we have additional questions that we'll provide some context to. I will also send everybody a copy of the summary report on the survey that we did, so that you have that as well for reference. Thank you again for your attention, and we look forward to a very exciting year for graphene in 2021 as we move forward. So thank you, everybody.